Good morning, my dear students. In this particular video presentations, we'll continue with the remaining problems from exercise 7.3 on integration from NCERT textbook. 19th problem in that exercise, it goes like this: integral dx by sin x into cos cube x. I will just write this as, I'll just multiply and divide by cos x in the denominator. I'll take this to the numerator. This becomes secant power 4x by this becomes tan x. Can be written as secant square x into secant square x. I make it into 2 secant square x. I make it into 2 secant square x. Secant square x into secant square x dx divided by tan x. Can also be written as 1 plus tan square x by tan x into d of tan x. D of tan x is nothing but secant square x. This can be written as 1 plus t square by t dt, where my t is tan x, which is integral dt by t plus integral t dt, which is nothing but log mod t plus t square by 2 plus c, which is log mod tan x plus tan square x by 2 plus c. Let me just check the whole answer. Integral dx by sin x into cos cube x, that is the question given to you. I mean to say, multiply and divide by cos x in the denominator. Now for denominator becomes tan x. This cos power 4x is taken to the numerator and written as secant power 4x. This secant power 4x can be written as secant square x and secant square x dx. This is nothing but 1 plus tan square x into d of tan x by tan x. This is nothing but tan x. Sorry, this is x, tan x. Okay, this is tan x. D of tan x is secant square x dx. Whenever I have d of something, I should multiply dx also. I explained in many videos. Now whatever is written as d of should be my substitution. 1 plus t square by t dt, where t is tan x. This can be written as integral dt by t plus integral t square by t is t anyway. Integral dt by t is log mod t plus t square by 2 plus c. Now for log mod tan x plus tan square x by 2 plus c is the final answer. The 20th problem goes like this: integral cos 2x dx by cos x plus sin x the whole square. This can be written as cos square x minus sin square x dx, using one of the formulae for cos 2a, cos x plus sin x the whole square. Let me just use a plus b into a minus b in the numerator. Cos x plus sin x into cos x minus sin x dx by cos x plus sin x the whole square. 1 cos x plus sin x gets cancelled, but I should have a clear observation. Derivative sin x is cos x is minus sin x, which is there in the numerator. I write it as d of sin x plus cos x by sin x plus cos x, which is of the form integral dt by t, where my t is the denominator, sin x plus cos x, which is nothing but log mod t plus c, which is log mod sin x plus cos x plus c. Let me just repeat the whole process. Integral cos 2x dx by cos x plus sin x whole square is the question given to you. I will use the direct first formula for cos 2x is nothing but cos square x minus sin square x. I am just using the formula of a square minus b square in the numerator. I split it as cos x plus sin x into cos x minus sin x. 1 cos x plus sin x gets cancelled. Cancelling the 2 means it becomes 1. It becomes 1. I have a clear observation. Derivative sin x is cos x. Cos x is minus sin x is there in the numerator. D of means I should multiply dx. Whatever is written as d of should be my substitution. This is the form dt by t, where t is my denominator. Sin x plus cos x. Now integral dt by t is log mod t. log mod sin x plus cos x plus c is the final answer. It is not at all difficult to follow. Everything comes only out of practice. You just go through once and then you'll be able to strictly follow how we go about the steps. It is not at all difficult. It is not at all difficult. It's an easy task to do. It is an easy task to do. Just you need practice. You need practice. It will be always easier. The next problem goes like this. 21st sum, it goes like this. Integral sin inverse cos x dx can be written as sin inverse sin pi by 2 minus x dx. Whenever you are given sin inverse sin theta, but theta is in the principal value branch of range of sin inverse, that is a closed interval minus pi by 2. Pi by 2 minus x is an angle first quadrant itself. Now for this will get reduced to simply pi by 2 minus x dx. Since just recall sin inverse sin theta is equal to theta, where theta belongs to the closed interval minus pi by 2 pi by 2. Here pi by 2 minus x belongs to minus pi by 2 pi by 2. For this automatically gets reduced to pi by 2 integral dx minus integral x dx, which is reduced to pi by 2 minus x by x square by 2 plus c. It's better to write the reason why I am writing this as pi by 2 minus x. It's better to write the reason why we are writing it as pi by 2 minus x. I repeat, integral sin inverse cos x dx can be written as integral sin inverse sin pi by 2 minus x. Sin pi by 2 minus theta is cos theta. Even in 10th standard students are learning. This can be replaced by simply pi by 2 minus x because sin inverse sin theta is theta, provided theta is in the principal value branch of range of sin inverse x. But pi by 2 minus x is an angle in this interval. Therefore, it gets reduced to pi by 2 minus x. Pi by 2 integral dx minus integral x dx. Pi by 2x minus x square by 2 dx. If you want, you put it in brackets. The x is not in denominator. X should be in the numerator. Or you can very well write this as pi x by 2 minus x square by 2 plus c. Remember the reason carefully. Then 22 second sum. It is of course a lengthy process. Anyway, I'll explain. It is not at all difficult. What I will do is I'll write the numerator as sin a minus b dx and divide by sin a minus b outside being a constant. Now I will write this sin a minus b within the integral as sin of x minus b minus x minus a dx divided by cos x minus a into cos x minus b. Just see here, x gets cancelled, minus of minus a minus b can be written like this. Now you know very well sin a minus b formula is sin a cos b minus cos a sin b. Let me use the formula here. Sin x minus b cos x minus a minus cos x minus b sin x minus a whole divided by cos x minus a into cos x minus b. Let me make it into two integrals. 1 by sin a minus b integral sin x minus b into cos x minus a by cos x minus a into cos x minus b dx minus 1 by sin a minus b is already there. 1 by sin a minus b is anyway there. 1 by sin a minus b is 1 by sin a minus b into integral I have cos x minus b into sin x minus a into sin x minus a into sin x minus a dx sin x minus a dx divided by cos x minus a into cos x minus b. Here cos x minus a gets cancelled. Here cos x minus b gets cancelled. Is 1 by sine a minus b into, recall, derivative cos x minus b is minus sine x minus b. Multiply two minus signs here. Minus sine x minus b dx by cos x minus b. Take this minus sign inside. 1 by sine a minus b integral minus sine x minus a dx divided by cos x minus a. In both the cases, derivative denominator is there in the numerator. In both the cases, derivative denominator is there in the numerator. Okay, so the form dt by t, I'll be able to write log. Now for minus 1 by sine a minus b, I am avoiding substitution. I write it as log mod cos x minus b plus 1 by sine a minus b into log mod cos x minus a plus c. Taking 1 by sine a minus b as common and using division rule of logarithms, it becomes 1 by sine a minus b into cos x minus a by cos x minus b plus c. That will be the final answer. That will be the final answer. That will be the final answer. Okay, I repeat the whole process. This is the question given to you. Integral dx by cos x minus a into cos x minus b. Multiply divided by sine a minus b. It comes only out of practice. Okay, sine a minus b being a constant, I am writing 1 by sine a minus b outside the integral. I should not take any variable outside the integral. This a minus b can be written as x minus b minus x minus a. I need it, therefore I do. In terms of x, I'll be able to write x minus x gets cancelled. Minus of minus a plus a minus b is written like this. Let me use sine a minus b formula here. Sine x minus b cos x minus a minus cos x minus b sine x minus a by the denominator as it is. Sorry, dx is anyway there. I forgot to write dx. Now make it into two integrals. 1 by sine a minus b integral sine x minus b cos x minus a dx by the denominator minus 1 by sine x minus a minus b into integral cos x minus b sine x minus a dx by this much. Here cos x minus a gets cancelled. Here cos x minus b gets cancelled. But have a clear observation. Derivative cos of any value is sine of the same value. If I multiply two minus signs, the first term, the second term, take this minus sign inside. This is the form dt by t. T is cos x minus b. I am avoiding that for log of the denominator. This is the form du by u, where u is cos x minus a. I am avoiding that part. Log mod this. Taking 1 by sine a minus b as common, I get log cos x minus a by cos x minus b plus c. Using your division rule of logarithms. We use division. Sorry for the interruption. The 23rd sum goes like this. Integral sin square x minus cos square x dx by sin square x cos square x. Let me divide individually. Sin square x dx by sin square x cos square x minus integral cos square x dx by sin square x cos square x. Here sin square x is cancelled. Here cos square x is cancelled. Integral secant square x dx minus integral cosecant square x dx, which gets reduced to tan x plus cos x cot x plus c, because derivative tan x is secant square x, derivative cot x is minus cosecant square x. Now for the here answer is A. Answer is A in the textbook. Then integral e power x into 1 plus x dx divided by cos square x e power x. If you observe carefully, numerator is d of x e power x by cos square x e power x. Just apply product rule. X into e power x is e power x into 1. That is e power x into 1 plus x dx. This can be simply written as integral secant square x dt, where my t is x e power x, which is nothing but tan t plus c. which is tan x e power x plus c. I repeat, integral e power x into 1 plus x dx by cos square x e power x. Numerator is nothing but d of x e power x by cos square x e power x, which is integral secant square t dt, but t is x e power x. For tan t plus c, which is tan x e power x. Therefore, my answer here is B. For the previous one, the answer is A. For the current one, answer is B. It is not at all difficult to follow. Anyway, the rest will continue in the next video. Thank you, students, for patient watching.